Welcome. Today we will see linearization of nonlinear functions. Now what is meant by nonlinear functions? Nonlinear functions means if we will plot the graph of the two elements x versus y axis, therefore that graph will not be a straight line. That graph may be curved. Therefore, such type of functions are called as nonlinear functions. Now, first of all, we will see some theories and then I will explain problems, that is how to solve problems of nonlinear functions by using partial differential equation. Now, linearization of nonlinear functions. The most powerful methods of system analysis have been developed for linear control systems. For a linear control system, all the relationships between the variables are linear differential equations, usually with constant coefficients. The reason that differential equations rather than algebraic equations are obtained is that in feedback control systems, the variables are functions of time. For example, in controlling temperature, the actuating signal causes a change in heat flow, but time is required for this added heat to bring the temperature to its desired value. In speed control systems, the actuating signal causes a change in power of the prime mover, but time is required for the engine to accelerate or decelerate to its desired speed. Similarly, in pressure control systems, it takes time to bring the pressure in a chamber to some desired value. That means what? What are these examples? If we have to control the temperature, therefore it will take certain time to bring the temperature to the desired value. Suppose we have to now boil the water. Now what we are doing, we are placing cold water in the pot and then we are putting it on gas stove, and then that gas is there, it is started heating that water. Therefore, suppose that boiling temperature of water is 100 degrees Celsius. Immediately when you will put the pot on the gas, immediately the temperature will not reach 100 degrees Celsius. It may take 5 to 10 minutes to reach the water temperature at 100 degrees Celsius. Similarly, in case of speed control system, now all of we are driving two-wheeler and four-wheeler. Now we are knowing that suppose we are driving the vehicle at a speed of 50 km per hour and we have to come down to up to 30 km per hour speed. Therefore, if you will decrease your accelerator, immediately speed will not reach from 50 to directly 30 km per hour. First of all, it will reach up to 45 km per hour. Again it will reach to 40 km per hour. Again it will reach to 35 km per hour. And again at last it will reach to 30 km per hour. Therefore, decrease in speed from 50 km per hour to 30 km per hour, it will take certain time. Similarly, in case of pressure control system, whatever suppose that pressure cooker is there, that is nothing but pressure control system. We are knowing that we are cooking foods in the pressure cooker. Therefore, for cooking food also in the pressure cooker, it takes time to cook the food. Therefore, this is nothing but variation of this time. That is, some time is required to bring the system to its actual position. That is, here all the variables are functions of time. Next, actual control systems usually contain some non-linear elements. Such elements would in turn yield non-linear differential equations for the system. That is, in actual control system, some elements are non-linear elements. Non-linear elements means what? They are not varying with respect to time, means their variation with respect to time is random or non-linear. Therefore, in the following we show how the equations for non-linear elements may be linearized. Thus, the resulting differential equation of operation for the system becomes linear. A linear equation in the n variables x1, x2, x3 dot 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 xn, which has the form y is equal to yi plus c1 x1 plus c2 x2 plus dot 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 plus cn xn, where c1, c2 dot 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 cn and yi are constants. Note that each of the n variables is to the first power and that no products of these variables appear. A non-linear equation results if one or more of the variables is to some power other than the first power. For example, xn raised to 3. If the equation contains products of the variables, for example, x2 into x5. Therefore, this is nothing but non-linear. Which are the non-linear variables? If there exist some products or if the variable is having power more than 1. That is x square, x cube, x raised to 4, x raised to 5, x raised to 6. If such type of variable is there, then we can say that that equation consists of non-linear equation. Or if there is a product between two variables, that is x, y or sin x cos y, tan x cos y, such type of functions are known as non-linear functions or non-linear equations. Now, therefore, this curve is there, that is y is equal to x square. This is the parabola. This is the point is xi yi. This is the point xy. This small x from the graph, you are observing that small x is nothing but x minus xi, and this small y is nothing but, what is the value of small y? Small y is equal to y minus yi from the graph. Therefore, such type of this variation, that is value of small x and value of small y, we have to obtain in while solving examples also. That is small x is equal to capital X minus xi, and small y is equal to, from the graph, this is small y is equal to y minus yi. Therefore, a plot of the non-linear relationship y is equal to x square is shown in figure. In the vicinity of the point xy, this is the point xy, the function is closely approximated by the tangent. For example, consider the point xy on the curve. This is the point xy on the curve of the non-linear function. The abscissa x is displaced by distance x from xi. This abscissa x intersects the non-linear function a vertical distance y plus epsilon from yi. Therefore, from yi, this is the yi length, it intersects this at y plus epsilon and it intersects the tangent distance y from yi. Therefore, the equation for y is y is equal to yi plus y small y plus epsilon, which is equal to yi plus small y, where epsilon is very small, that's why we have neglected it. Therefore, capital Y is equal to yi plus small y, where small y is equal to y minus yi. Therefore, lower case letters indicate the variation of the capital letter parameters from the reference point. From figure, the slope of the tangent line is y by x is equal to dy by dx at the reference point I is equal to slope at point xi yi. Therefore, the symbol with reference to I means that the derivative is to be evaluated at the reference point. Thus, that is, this symbol indicates that the derivative is to be evaluated at the reference point. Therefore, thus small y is equal to dy by dx at the reference point I into x, which is equal to d by dx of x square at the reference point I into x into small x, which is equal to, what is the derivative of x square? Derivative of x square is 2x. Therefore, 2x, and at the reference point I, therefore 2xi into small x. Therefore, small y we are getting it as 2xi into x. Therefore, next, therefore capital Y is equal to, what is our equation? Yi plus small y. Therefore, substituting the value of small y in this equation, we are getting capital Y is equal to yi plus 2xi into small x. Now we will see problems based on this. Therefore, first problem, effect a linear approximation for the equation y is equal to x square for the values of x in the neighborhood of 10 and find the error when you use this approximation for x is equal to 11. Therefore, what solution? At xi is equal to 10, what is yi? Yi is equal to xi square. Therefore, yi is equal to 10 square. Therefore, yi is equal to 100. What we have to done? We have taken this equation y is equal to x square. Y is equal to x square. This equation we have taken and we have substituted, or we have found out value of yi at xi, that is yi is equal to xi square. Therefore, what is the value of xi? Xi is equal to 10. Therefore, yi is equal to 100. Now, what is small x? Small x is equal to x minus xi, where x is, therefore small x is equal to 11 minus 10, which is equal to x is equal to 1. Therefore, we will differentiate now this small y is equal to x square, that is y is equal to x square, by using partial differential equation. Therefore, y is equal to yi plus 2xix. This 2xix already this equation we have obtained in theory. Therefore, y is equal to 100 plus 2 into 10 into 1. Therefore, y is equal to 120. Therefore, this y is equal to 120, that is nothing but this approximate value of y. And this is yi is equal to 100. This is nothing but value of y at the reference point. Now, next example. Example 2. For the triangle shown in figure, this is the triangle shown in the figure. The length of the base is x. The length of the adjacent side is y. And the included angle is theta. The altitude h is y sin theta. the equation for the area of a triangle, 1/2 the altitude times the base, may thus be written in the form A is equal to 1/2 xy sin theta. Determine the linear approximation for the area A. For the area A, the reference values are xi is equal to 10, yi is equal to 16 and theta I is equal to 30 degree. Determine the approximate area when x is equal to 9, y is equal to 18 and theta should be here, theta is equal to 33 degree. Therefore, this is the triangle and we have to find out its approximate area. This value is theta is equal to 33 degree. Therefore, solution. The reference value of the area is, now what is our area? A is equal to 1/2 xy sin theta. Therefore, we have to find out this area at the reference positions. What are the reference positions? That is nothing but at the point I. Therefore, these are the given data. Xi is equal to 10, yi is equal to 16, theta is equal to 30 degree, x is equal to 9, y is equal to 18, and here also theta should be equal to 30 degree. Don't consider it as theta I. This is theta is equal to 33 degree. Therefore, the reference value of the area is AI is equal to 1/2 xi yi sin theta I. Therefore, substituting the values, AI is equal to 1/2 into 10 into 16 into sin 30. Therefore, AI is equal to 1/2 into 160 into 0.5. Sin 30 is equal to 0.5. Therefore, AI is equal to 40. Equation 1. Therefore, we have got value of area at the reference point, that is AI is equal to 40. Now next, the change in area small a. The change in area small a is given by the equation. Small a is equal to dou a by dou x into x, dou a by dou y into y, and dou a by dou theta into delta theta. Therefore, these partial differentials we have to evaluate at the point I, that is dou a by dou x at the reference point I into x plus dou a by dou y at the reference point I into y plus dou a by dou theta into at the reference point I into delta theta. Therefore, now we will substitute value of a in this equation. What is value of a? 1/2 xy sin theta. Therefore, dou by dou x of dou a is equal to dou by dou x of 1/2 xy sin theta into I into small x plus dou by dou y of 1/2 xy sin theta at reference point I into small y plus dou by dou theta of 1/2 xy sin theta at the point I into delta theta. Therefore, by using partial differential equation, small a is equal to 1/2 y sin theta at the reference point I into x plus 1/2 x sin theta at the reference point I into small y plus 1/2 xy cos theta, that is differentiation of sin theta is cos theta at the reference point I into delta theta. Therefore, we are knowing that AI is equal to what? 1/2 xy sin theta at the point I, that is 1/2 xi yi sin theta I. Therefore, what we will do, we will substitute this value in earlier equation. Therefore, we will get this equation, that is small a is equal to 1/2 xy sin theta at the reference point I into small x upon capital X plus 1/2 xy sin theta at the reference point I into small y upon capital Y plus 1/2 xy sin theta at the reference point I into delta theta upon tan theta I. Therefore, this is our equation. Now, in this equation, this 1/2 xy sin theta at the point I is nothing but AI. Therefore, small a is equal to AI will take common. Therefore, what is the remaining equation? Small a is equal to into bracket x upon xi plus y upon yi plus delta theta upon tan theta I into AI, that is equation 2. Therefore, what is small x? From graph we have seen last time, that is in the previous slide, small x is equal to x minus xi, which is equal to 9 minus 10, therefore small x is equal to minus 1. Similarly, small y is equal to y minus yi, which is equal to 18 minus 16, therefore small y is equal to 2. Now delta theta is equal to theta minus theta I. What is theta? 33 degree, minus theta is 30 degree, therefore 33 minus 30 into pi by 180, therefore delta theta is equal to pi by 60 radian. Therefore these values we will put here and value of AI we will put, therefore we will get value of small a. Therefore small a is equal to minus 1 divided by 10 plus 2 divided by 16 plus 5 by 60 into tan 30 into 40. Therefore by doing this calculation we are getting small a is equal to 4.63. Therefore we will find out approximate value of a. Therefore the approximate total area a is a approximate is equal to AI plus small e. Therefore value of AI we are knowing, that is AI is equal to 40 plus 4.63. Therefore a approximate we are getting it as 44.63. Therefore this is our second problem. Now we will see third problem. Example 3. For the triangle shown in figure, it follows from the law of sines that sin alpha upon A is equal to sin beta upon B. Therefore sin beta is equal to B upon A into sin alpha. Therefore effect the linear approximation for the change in delta beta in angle beta due to a change small a in area or small a in the length of the side, that is capital A change in small b in the length of the side, that is capital B, and a change in delta alpha in alpha. For alpha I is equal to 30 degree, beta I is equal to 120 degree, and AI is equal to 10. Therefore determine the variation of delta beta when delta alpha is equal to 2 degree, A is equal to 1 and B is equal to 1. Therefore we will find out the solution. Now which equation they have given? Sin beta is equal to B divided by A upon sin alpha. Therefore sin beta is equal to B divided by A into sin alpha. Therefore we will differentiate this equation. Now here three variables are there, B, A and alpha. That is beta is a function of three variables, B, A and alpha. Therefore the left side is a function of beta and the right side is a function of A, B and alpha. Thus the general form of the linearized equation is, therefore we will differentiate it by partial differentials. Dou by dou beta of sin beta into delta beta is equal to dou by dou A of B upon A sin alpha into alpha plus dou by dou B of B upon A sin alpha into small b plus dou by dou alpha of B upon A sin alpha into delta alpha. Therefore by differentiation we are getting the values, that is the resulting linearized equation is. Now what is differentiation of sin beta? Cos beta. Therefore cos beta at the point I into delta beta is equal to minus B upon A square into sin alpha at the point I into small a plus sin alpha upon A into small I at the point small I into small b plus b upon a cos alpha, that is differentiation of sin alpha is cos alpha, b upon a cos alpha at the reference point I into delta alpha. Therefore, what we will do, we will take b upon a sin alpha outside, b upon a, capital B upon a sin alpha outside these three terms. Therefore, what will remain here is equal to b upon a sin alpha at the reference point I into bracket minus small a upon ai plus small b upon bi plus delta alpha upon tan of alpha I. Therefore, solving for delta beta yields. Therefore, what will happen? What will now delta beta? Therefore, this cos beta is there. We will take on this side. Therefore, cos beta is multiplied here. Therefore, on this side, when it will come, it will become divided by. Therefore, delta beta is equal to b upon a. Delta beta is equal to b upon a. That is sin beta I divided by cos beta I. This b upon a into sin alpha, it is replaced by sin beta, because our main equation is sin beta is equal to b upon a sin alpha. Therefore, this b upon a sin alpha, it is replaced by sin beta I divided by this cos beta I will come here into this bracket will remain as it is, that is small a upon ai minus small a upon ai plus small b upon bi plus delta alpha divided by tan of alpha I. Therefore, we will find out values of now small a, small b, delta alpha. Already I think they have given. Now, therefore, beta I is equal to, or bi is equal to ai into sin beta I divided by sin of alpha I. Therefore, ai is equal to 10 into sin of 120 degree divided by sin of 30 degree is equal to 10 root 3. Next, alpha I is equal to 2 degree they are given. Therefore, 2 into pi by 180 is equal to 0.0349 radian, because angle value we have to convert it into radian. Next, therefore, delta beta is equal to, what is our, this is our original equation, that is what we have obtained, sin beta I upon cos beta I into bracket minus small a upon ai plus small b upon bi plus delta alpha upon tan of alpha I. Therefore, this is sin beta upon cos beta is nothing but tan beta. Therefore, beta I they have given it as 120 degree. Therefore, tan of beta I is equal to tan of 120 degree into bracket small a, that is minus 1 upon 100, sorry, minus 1 upon 10 plus 1 upon, what is the value of bi? Bi is equal to 17.32 plus 0.0349, that is this delta alpha 0.0349 divided by tan of 30. Therefore, delta beta we are getting it as minus 0.314 radian, which is equal to minus 1.8 degree. Therefore, this is our final solution. Now, we will see next example. Determine, that is example number 4, determine the linear approximation for each of the following functions. That is small a, that is first problem in that y is equal to root x, second y is equal to 1 upon root x. Therefore, for xi is equal to 100, use this approximation to evaluate y is equal to evaluate y when x is equal to 98. Therefore, two values they have given, x is equal to 98 and xi is equal to 100, and we have to find out approximate value of y of these two functions, that is y is equal to root x and y is equal to 1 upon root x. Therefore, we will find out the solution. So, here xi is equal to 100, that is reference value or mean value, and x is equal to 98, that is exact value. Therefore, this is first function, y is equal to root x. Therefore, the reference value is, what is reference value? That is at the point I. Therefore, yi is equal to root of xi. What is the value of xi? Therefore, yi is equal to root of 100. Therefore, yi is equal to 10. That is equation 1. See, therefore, again, next, the variation small y is given by small y is equal to dou y by dou x at the reference point I into x. Therefore, substitute value of capital Y here. Substitute value of capital Y here. Therefore, what we are getting? Dou by dou x of root x at the point I into x. Dou by dou x of root x at the point I into x. Therefore, what is the differentiation of root x? 1 upon 2 root x at the point I into small x. Therefore, which is equal to 1 upon 2 into root of xi into small x. Now substitute the value of small x and xi in this equation. Therefore, small y is equal to 1 upon 2 root 100 into small x. Therefore, y is equal to 0.05 into small x, equation 2. Now we will find out value of small x because we have not found out value of small x. Therefore, x is equal to x minus xi, which is equal to 98 minus 100. Therefore, x is equal to minus 0.2. Therefore, substituting this value in the previous equation, we are getting, therefore, from equation 2, what is equation 2? Small y is equal to 0.05 into x. Therefore, 0.05 into 0.05 into minus 2. Therefore, which is equal to y is equal to 0.1. That is small y is equal to 0.1. Sorry, minus 0.1. Therefore, the approximate value of the y is, that is y approximate is equal to capital yi plus small y. What is the value of yi? 10. What is the value of small y? Minus 0.1. Therefore, 10 minus 0.1 is equal to 9.9. That is y approximate is equal to 9.9. Similarly, we will take next point, that is y is equal to 1 upon root x. Therefore, y is equal to 1 upon root x. Now again we will find out reference value. See that same steps are there again and again. Therefore, yi, that is the reference value yi is equal to 1 upon root of xi. Therefore, 1 upon root of 100. Therefore, yi is equal to 0.1. That is equation 1. Now what we will do, we will differentiate this equation, that is y is equal to 1 upon root x by x. Therefore, the variation in small y is given by small y is equal to dou y by dou x at the point I into x. Therefore, dou x of 1 upon root x into at the point I into small x. Therefore, dou by dou x of what is x 1 upon root x raised to minus 1 by 2. Therefore, dou by dou x of x raised to minus 1 by 2 into small x at the point I. Therefore, by differentiation, what we are getting, small y is equal to minus 1 by 2 into x raised to minus 3 by 2 at the point I into small x. Therefore, small y is equal to, what is xi? Xi is equal to 100. Therefore, small y is equal to minus 1 by 2 plus 100 raised to minus 3 by 2 into small x. Therefore, y is we are getting it as 0.005 into x. That is 5 into 10 raised to minus 4x. Therefore, small y is equal to minus 5 into 10 raised to minus 4 into small x. Therefore, we will find out value of small x. Small x is equal to x minus xi, which is equal to 98 minus 1000. Therefore, small x is equal to minus 2. Therefore, we will substitute this value of small x in equation 2. We are getting from equation 2 y is equal to minus 5 into 10 raised to minus 4 into small x. Therefore, small y we are getting it as minus 5 into 10 raised to minus 4 into minus 2, which is equal to y small y is equal to 1 into 10 raised to minus 3. Therefore, small y value we got, that is variation. yi value are knowing. Therefore, the approximate value y approximate is equal to yi plus y. Therefore, 0.1 plus 1 into 10 raised to minus 3, which is equal to y approximate is equal to 0.101. Now we will see next example. Determine the linear approximation for each of the following functions. Therefore, first function is y is equal to sin x, second function is y is equal to tan x. Therefore, for xi is equal to 30 degree, use this approximation to evaluate y when x is equal to 33 degree. Therefore, two values of x they are given, x is equal to 33 degree and xi is equal to 30 degree. Therefore, solution. Here xi is equal to 30 and x is equal to 33 degree. Therefore, what is our first equation? Y is equal to sin x. Therefore, we will differentiate this sin x partially. Therefore, dou y by dou x, that is the reference value of yi is equal to sin of xi. Therefore, which is equal to sin of 30 degree. Therefore, yi we are getting it as 0.5. This is the reference value of y. Now next, x is equal to x minus xi. Therefore, which is equal to 33 degree minus 30 degree, which is equal to 3 degree. But we want values should be in radian. Therefore, multiply by pi by 180. Therefore, x is equal to 3 degree into pi by 180. Therefore, x is equal to 0.0523. Therefore, the variation y is equal to dou y by dou x at the point I into x. Therefore, y is equal to dou by dou x of sin x at the point I into x. Therefore, what is the differentiation of sin x? Cos x. Therefore, cos x at the point I into x, which is equal to cos of xi into x. Therefore, what is xi? Xi is equal to 30 degree, that is cos of 30 degree into 0.0523. Therefore, we are getting value of small y is equal to 0.0453. Therefore, the approximate value of y is, therefore y approximate is equal to yi plus small y. Therefore, substituting the values, which is equal to 0.5 plus 0.0453. Therefore, y approximate is equal to 0.5453. This is for y is equal to sin x. Now, next problem in this problem it says, that is y is equal to tan x. Now again, the reference value yi is, therefore yi is equal to tan of xi. Therefore, substituting value of xi is equal to 100 here. Therefore, xi is equal to 30 degree. Therefore, yi is equal to tan of 30 degree, which is equal to yi is equal to 0.05773. This is the reference value of y at the reference point. Next, the variation small y is, what is variation of small y? Small y is equal to dou y by dou x at the point I into x. Therefore, substituting the values, small y is equal to dou by dou x of tan x at the point I into x. Therefore, y is equal to sec square x at the point I into small x. Therefore, small y is equal to, what is partial differentiation of tan x sec square x, and what is the inverse sec square x? Sec square x is equal to 1 upon cos square x. Therefore, we can write y is equal to 1 by 2 cos square x at xi into small x. Therefore, 1 by 2 cos square 30 degree into 0.0523. Therefore, small y is equal to 1.33 into 0.0523. Therefore, small y is equal to 0.0698. Now, we will find out approximate value of y. Therefore, the approximate value y approximate is equal to yi plus small y. Therefore, substitute value of yi and small y. Therefore, what is the value of yi? 0.0577 plus 0.0698. Therefore, making addition, we are getting y approximate is equal to 0.647. Therefore, we will stop here, and in the next lecture we will see more problems. Thank you very much.